The 5 biggest mysteries of the universe. The universe is the greatest mystery humanity has ever faced. For thousands of years, human beings have looked at the night sky and wondered what the stars really are, how the universe began, and what hidden forces shape the reality we experience. Ancient civilizations created myths and stories to explain the cosmos, imagining gods, spirits, or cosmic beings responsible for the structure of the heavens. Today, science approaches these questions in a completely different way. Using powerful telescopes, advanced mathematics, and complex experiments, physicists and astronomers have revealed extraordinary details about the universe. We now know that the Earth is not the center of the cosmos, that galaxies contain billions of stars, and that the universe itself is expanding across unimaginable distances. Yet despite all the knowledge humanity has accumulated, the deeper science explores the universe, the more it discovers that some of the most fundamental questions about reality remain unanswered. In fact, some of the greatest mysteries in physics today involve things we cannot see, forces we cannot fully explain, and events that challenge the limits of our current understanding. One of the biggest mysteries in modern science is dark matter. When astronomers observe galaxies, they notice something deeply puzzling. Stars orbit around the center of galaxies at extremely high speeds, far faster than they should. If only the visible matter in those galaxies were responsible for gravity. According to the laws of physics, galaxies rotating at those speeds should tear themselves apart, with stars flying outward into empty space. Yet that does not happen. Instead, galaxies remain stable and hold together over billions of years. This observation led scientists to propose that there must be an enormous amount of invisible matter surrounding galaxies, creating additional gravity that keeps them intact. This invisible substance was given the name dark matter. Unlike ordinary matter, dark matter does not emit light, reflect light, or interact with electromagnetic radiation in any detectable way. It cannot be seen with telescopes, yet its gravitational effects are clearly visible in the motion of galaxies and clusters of galaxies. Today, scientists estimate that dark matter makes up roughly 85% of all matter in the universe, meaning that everything we can see, stars, planets, and gas clouds, represents only a small fraction of what actually exists. Despite decades of research, the true nature of dark matter remains unknown. Physicists have proposed many possibilities. Some believe dark matter may consist of new types of particles that have not yet been detected. Others suggest that it could involve exotic forms of matter that interact only through gravity. Large underground laboratories have been built to search for dark matter particles and powerful particle accelerators attempt to recreate conditions where such particles might appear. Yet so far, none of these experiments have provided definitive answers. This means that one of the most important components of the universe is still completely mysterious. We know dark matter must exist because we can observe its gravitational influence, but we still do not know what it actually is. Another profound mystery in modern cosmology is dark energy. In the late 1990s, astronomers studying distant exploding stars made a surprising discovery. They were measuring how fast the universe was expanding by observing supernova located billions of light years away. According to earlier theories, the expansion of the universe should gradually slow down over time because gravity pulls galaxies toward each other. But the observations revealed something unexpected. Instead of slowing down, the expansion of the universe was accelerating. Galaxies were not only moving away from each other, but doing so faster and faster as time passed. This meant that some unknown force was pushing the universe apart. Scientists named this mysterious phenomenon dark energy. Today, dark energy is believed to make up nearly 70% of the total energy content of the universe. Yet, we still do not know what dark energy actually is. Some physicists think it may be related to the energy contained within empty space itself. Others believe it may represent a new fundamental force that science has not yet discovered. Black holes represent another extraordinary mystery in physics. These objects form when massive stars collapse under their own gravity at the end of their lives. As the star collapses, its mass becomes concentrated into an extremely small region of space, creating a gravitational field so powerful that nothing can escape from it, not even light. For many years, scientists believed that anything falling into a black hole would disappear forever, lost beyond the event horizon from which no information could return. But in the 1970s, physicist Stephen Hawking made a remarkable discovery. By combining principles from quantum mechanics and relativity, he showed that black holes should slowly emit radiation. This phenomenon, now known as Hawking radiation, occurs because quantum fluctuations near the event horizon allow particles to escape the gravitational pull of the black hole over incredibly long periods of time. This radiation could cause black holes to gradually shrink and eventually evaporate completely. This idea creates a deep paradox in physics. If a black hole eventually disappears, what happens to the information about everything that fell into it? According to the laws of quantum mechanics, information about physical systems cannot be destroyed. Yet if a black hole evaporates entirely, it seems as though that information would vanish forever. This contradiction is known as the black hole information paradox. and it remains one of the most challenging problems in theoretical physics. Solving this mystery may require a deeper theory that unifies quantum mechanics and gravity, something scientists have been searching for decades. Another enormous mystery involves the origin of the universe itself. According to the Big Bang theory, the universe began approximately 13.8 billion years ago in an extremely hot and dense state. In the first fractions of a second, space expanded rapidly, cooling as it grew larger. As the universe expanded, fundamental particles formed, followed by atoms, stars, galaxies, and eventually planets. Observations of distant galaxies and the faint cosmic microwave background radiation strongly support this model. But while the Big Bang theory explains how the universe evolved from its earliest observable state, it does not fully explain why the universe exists in the first place. Scientists still do not know what triggered the Big Bang or what conditions existed before it occurred. Some theories suggest that the universe could have emerged from quantum fluctuations in empty space. Others propose that our universe may be only one region within a much larger structure called the multiverse, where countless universes exist with different physical laws. These ideas remain speculative, but they illustrate how profound the question of cosmic origins truly is. Understanding how the universe began may require entirely new theories of physics that go beyond our current models. Perhaps the deepest mystery of all concerns the fundamental nature of reality itself. For centuries, scientists believed that matter was composed of tiny solid particles called atoms. Later discoveries reveal that atoms themselves are made of even smaller components, such as electrons, protons, and quarks. But modern physics has taken this idea even further. According to quantum field theory, particles may not be fundamental objects at all. Instead, the universe is filled with invisible fields that exist everywhere in space. What we perceive as particles are actually small vibrations or excitations within those fields. In this view, reality is not made of solid objects moving through space, but of interacting fields and energy distributed across the universe. Some physicists believe that reality may even be fundamentally informational. In these theories, space, matter, and energy could emerge from deeper patterns of information that govern how physical systems interact. This idea suggests that the universe might behave more like a vast network of information processing rather than a simple collection of objects. Although these concepts remain theoretical, they highlight how radically our understanding of reality has evolved. All of these mysteries remind us that the universe is far more complex than we once believed. Despite centuries of scientific progress, humanity has only begun to explore the deepest layers of the cosmos. Each new discovery reveals additional questions waiting to be answered. Dark matter, dark energy, black holes, the origin of the universe, and the nature of reality itself remain open puzzles that challenge the limits of human knowledge. And perhaps that is the most inspiring aspect of science. The universe is not a finished story that has already been fully understood. It is a vast and evolving puzzle that humanity continues to explore. Every observation, every experiment, and every new theory brings us closer to understanding the cosmos, yet also reveals how much remains unknown. The universe still holds countless secrets, and somewhere among those mysteries may lie discoveries that will transform our understanding of reality forever. Still, within